Okay, this next class that we're going to have here, we're going to look at the parabola. Now, a parabola is a very important shape. It's a curve like this that gets drawn inside in a rectangle. Now, the reason I have it turned at a funny angle here is because I just wanted to point out the fact that satellites in space like sky sports and all those or sky channels, they're called sky channels because basically from wherever the cameras are in the sporting world, like America or England or wherever they beam their pictures up to the satellites. They can send them around the world and they're beamed back down to Earth, and a satellite dish is in the shape of a parabola. Now the satellite dish gathers them, and the parabola has a special property that when you beam in a signal that's coming down from space, it bounces it through a single receiver point here. Every single signal that comes in here gets bounced and reflected back through the collector point here, which is the focus of the parabola. So without realizing it, parabolas are already very important to humans. So I'm going to look here at drawing a parabola in a rectangle. So we'll just draw a random sized rectangle here. Now I'm drawing this heavy, but you would want to be drawing your parabola constructions light, but I'll do it heavy because I want to make sure that they come out in the camera. So we are going to draw a parabola like this. So we have got 3 points here. I'm going to call it the start, the E for end, and I'm going to just mark here the center. Okay, now the middle there, I'm going to call it V, which is going to be called the vertex, VERTEX, which is kind of the center point in the parabola. So our parabola is going to go up and back down here. So what we want to do is we're going to divide the height of this into 4 equal distances. So I'm just going to mark 4 tens. Okay, so there's 4 equal distances. Join the fourth one to the end of the line. Now I want to go parallel then from there. So parallel, just set up my sliding set square there. Okay, so that divides the height into 4 equal distances. And I'm just going to transfer these across now as well, because I'll be using these to draw the other half of the parabola as well. Okay, so we've divided the height into 4. Now I want to break half of the width into 4 as well. Now I will do that at the bottom. But I'll do it at the bottom because I have a bit more room. So I'm going to break half of the width into 4. So step out 4 equal distances, join the end of the lines. So the fourth goes to the end of the line here. Join that up, and then we'll go parallel. Okay. Now, these lines go vertical up towards the vertex, and the ones at the side go diagonally to the vertex. Okay, now the short one here middle to the middle, long to the long. So we now have half our parabola that I can draw this here now. And I'm going to do the same at the other side. So just join those up to the top, or to the vertex. And now I could mark these distances along the bottom with my compass and go vertically, or I can just step these heights across. Okay, so I'll just step those across, and that allows me draw the rest of our parabola. So that is the construction for the parabola. It doesn't involve knowing the division of a line. Now, after we have one done, what I want to look at next here now, or what I would recommend for practice for these, is just doing the same then. I'll actually draw these upside down. I'll do the next one upside down. So you draw your random sized rectangle upside down, because in this one we're going to want to start here, end here, and have a vertex in the middle. So again there, you'll be doing the division of lines to work out your 4 distances there, your 4 equal distances here. So the sides go to the vertex, these just come down. So that's half our parabola. And again there then, I'll just run through it again. So height into 4, half the width into 4, and they go to the vertex, these come down. So these are our points. Okay, and just adjust the camera there again. So we've done a normal shaped one, upside down one, and what I would recommend there then is that you just do some different shapes, like if we do one sideways and do one turn the other way. And what you could experiment with then is you don't have to use 4s, you could use a 5. So I'll just do this one with a 5, maybe 1, 2. Now all that matters is that you use the same number of spaces. Okay, that you use the same number of spaces in the construction. So if I divided 5 equal parts for half the width, and I have 5 equal parts here for the height, so though I'm doing these freehand, you can, and because it's symmetrical, you can bring your points across or do the construction again. So we'll draw a parabola like that, and maybe for the next one we'll just go with 3. So again, here's the vertex, Now, I'm not a great advocate or fan of just using 3 points or 3 divisions, because there's big distances to draw there then without any construction. But, and again, because that's symmetrical, you can just transfer them across the center line. Okay, so that's normal parabola, upside down parabola, vertex to the right, vertex to the left, and that's a good practice sheet there then for drawing parabolas. Now, the last thing I will just say about that is that the shape of a parabola actually comes from, if you can picture a cone standing on the ground like that. So there's the front view of a cone, and if you chop a cone, if you chop through a cone like that and chopped off a big piece of a cone like that, that shape that you get through cutting through a cone, of which I happen to have a cone here, and that cut there is parallel to the side of the cone, and that greeny shape that you can see here, that is a parabola. So that's where the shape comes from. So yeah, that's the lesson on parabolas. Let's go and get that done.